This video, we're going to prove the following theorem. For arbitrary integers a and b, a being congruent to b mod n is the same as the remainder when you divide, if the remainder when you divide a and b by n are the same. For example, if you divide 7 by 2 and you divide 3 by 2, I claim that 7 is congruent to 3 mod 2. And this is true because their difference is 2 times an integer. 7 divided by 2, it goes in 3 times, remainder 1. And 3 divided by 2 is 1, remainder 1. They have the same remainder. Okay, and if they have the same remainder, then these two numbers are congruent, in this case mod 2, because we're dividing by 2. The mod number, and usually denoted by n, is what you're dividing by. Okay, so it's an if and only if proof. So we need to go in the forward direction, and then when we're done in the reverse, going in the forward direction, then we have to go in the reverse direction. But of course, before that, need to ask you guys to subscribe to my channel if you just love seeing mathematical proofs, as that's all we do on this channel. One mathematical proof after another. Every video is a mathematical proof of a theorem or lemma or corollary. Sometimes two corollaries. Sometimes a theorem and some corollaries. Okay, so let's get into this. Hit the pause button, subscribe to my channel, then come back and view the video. So we're going to start off with a and b are arbitrary, and that a is congruent to b mod n. Well, that implies that a minus b is a multiple of n. In fact, it's if and only if. Well, that implies that a is b plus kn. We will come back to this in a moment. By the division algorithm, we know that b is a multiple of n plus r, where r is between 0 and n. I have that backwards, don't I? B is a multiple of n plus a remainder, and that remainder will be between 0 and n. Okay, so we found the remainder for b when you divide by n. It's r. Okay, now I want to show that a has the same remainder. Well, from right here, we know that a is b plus kn. But we just learned that b is qn plus r plus kn. Well, I'll combine the n's. K plus q or q plus k is an integer, and it gets multiplied by n plus r. It already defined r. R is between 0 and n. Okay, so what we've shown is that from the division algorithm for a is equal to a is equal to this multiple of n plus r, where r is where it should be, between 0 and n. And by the division algorithm, we show that when you divide b by n, you also get the same remainders. Okay, so we got the same remainders. Now we have to go in the reverse direction. Suppose that when you divide a and b by r, you get the same remainder. What does that give you? Okay, suppose when you divide a and b by n, you get the same remainder. Well, that implies that a is some multiple. Let's not use r. A is some multiple of n plus r, and b is a different multiple of n plus r. Those are the same because we're saying when you divide a and b by n, you get the same remainder. Well, what happens if you subtract? A minus b is un plus r minus vn plus r. Now remember, we want to show that a is congruent to b mod n. That is, I want to show that a minus b is some multiple of n. But I have it here. The r minus r cancels. You have un minus vn, which is u minus v, which is our integer, times n. Well, that's exactly what we wanted to show. This equaling this implies that a is congruent to b mod n, because this means that a minus b is a multiple of n. But that's just what I showed. A minus b is some integer multiple of n. And that finishes this video. If you like videos where we prove things all day long, as I mentioned, you should definitely subscribe to my channel. See you guys in the next video. Watch and learn.